There are three trig identities, which we will do videos to explain every step so you can review in your own time. The first is going to be number 10 from the trig identities worksheet. As you can see, the left-hand side of this equation is the more complicated side. I've highlighted it in red. Based on what we've done in previous examples, I think it's obvious that we're going to need to distribute or FOIL. Now, at this point, this looks very, very complicated, more so than where our answers should fall. We're going to use the strategy of converting everything into sines and cosines. By using our definitions, rewriting in its fractional form, this is what we are left with. Please remember, if you need more time to copy these down, please feel free to use the pause button. Now, if you notice, I have 4 separate terms separated by 3 plus signs. In the first term, the cosines will cancel. In the last term, the sines will cancel. By multiplying, this is what I'm left with. The next step is the newest algebra strategy that you have not used in any other examples. If we look at where we need to go, secant t plus cosecant t, your brain should tell you you could rewrite those in terms of sine and cosine as 1 over cosine t plus 1 over sine t. If I try to do LCD of the middle, which some of you may be inclined to do because you recognize a possible Pythagorean identity, the problem we have is it's going to up our exponents to 3's, which isn't going to help us, especially considering the answer that we're looking for. The new algebra strategy is to regroup. So notice the sine in the last line of work has moved to the end, and the cosine has moved to the front. I've changed the order of the terms. Now, I've used parentheses to group the terms. My next step is actually one you've seen before. We're going to use LCD, but we're not using the LCD of all 4 terms. We're actually going to use the LCD of the first parenthesis group, and then use LCD for the second parenthesis group. Now we can use our Pythagorean identities. Each of the numerators can be substituted with 1's. We can change them from fractional form back to their other definitions in order to accomplish the goal of getting what's on the other side of the equal sign in the initial problem.